Okay. Meantime, the participants who have joined us, can you can you think of a relation between the input and the filter size, uh, and how will that decide the output? Like if it is 7, in this case, when the input was 7 by 7 and the mask was 5, output that you got is 3. Let's assume, let's take an example where your kernel is of size 3 by 3. So if it is 3 by 3, can we all together think, or can you think for yourself that what is the size of the output? I can place it here, 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 and here. So in that case, the size of the output will be 5 by 5. So the takeaway in this particular case is the output will depend on the input and the filter. Uh, this was without padding. Now we all know that if I introduce the concept of padding, which we have already seen, the size of my output will change. So the same 7 by 7 image which we had taken earlier, same when I zero pad it, you know the concept of this padding. I can either go for zero padding, or I can go for or I can also go for pixel duplication. So whatever I do or whatever I choose to do, I want you people to note that moment I introduce padding, the output size is going to change. So the same example, it is 7 by 7, the input is 7 by 7, and now you have added one extra row along each side. So it is 2 rows horizontally and 2 rows vertically. The size of the output image will change. So now I can have this as, I can place it here, I can scroll it to the next bit, I take it still further and still further and still further. So the output size that I have will keep on accordingly changing. So what have we seen earlier is the output here, we saw that it depends on only input. If there is no padding, we know how much size will be changing. If there is a padding, my size will further change. The next concept that we need to know in CNN is strides. So even based on strides, my size of the output will change. What do I mean by strides? At what distance am I moving? So if you see this diagram here, I have placed the kernel at this position, and now I am taking stride of 2. So in the next image, I leave this and I go here. I am taking stride of 2. So I'll move ahead by 2 pixels. All the examples that we have seen earlier, your stride was 1. We used to move down to all the consecutively placed pixels. Now we are taking stride of 2. So I take this particular, I considered this pixel, then I moved to the alternate one, where is it is the stride of 2. Then after moving to this, I did not put my mask on the next pixel. Instead, I have chosen to do it on the next one. Similarly, so when I'm choosing the strides, again the size of my output image is going to change. The size of the output image when I take it alternatively, size of my output image when I go for padding, size of the output image when I do not go for padding, and size of the output image when I take it consequently. For all these cases, the size of the output image will depend on all this. So if I take you back quickly, the bit that we are seeing is relation between the input, the output size, and the filter size. All these things will matter. So if you have to summarize it all, please understand this is the formula which you will be using. Okay, so output width is equal to input width minus f. What is f? F is the spatial extent of the filter, the depth of the filter, which usually we are taking it same as the input image, plus 2p plus 1 upon the first component upon s. So s is nothing but the stride, p is padding, f is the extent, w1 is the width of the original image, w2 is the width of the output, h2 is the height of that output, sorry, H2 is the height of the input. Sorry, what am I doing? H2 is the height of the output, H1 of the input, P padding, S is nothing but stride, F is nothing but extent. So this is the formula which will give you the relation. So if you see the university paper, um, uh, previous university paper, there is a problem based on this. And let us take up one problem. I'll come to this diagram again. Let me take an example first. So here, please understand, this is the image 32 by 32 input image. The depth is 1. The depth of the filter, the kernel that I'm using is also 1. The kernel is 5 by 5. And we need to find out what is the dimension of the output. Please understand there are 6 filters, 6 such filters that are taken. Stride is 1 and there is no padding that is being taken. Are you getting it? So there are 6 such filters. What do I mean there are 6 such filters? If I take you back quickly to this diagram, do you remember? I will have, everybody, can you see this? All of you? All of you? Are you all with me?
Yes, ma'am. Yes, ma'am.
Getting an idea very properly?
Yes, ma'am.
Okay, so I'll go back to sharing and would like to bring all of you here. Okay, so I wanted you to quickly, yeah. Okay, so here we go. So do you remember this diagram? We can have multiple filters. One image, I can have multiple filters. I can choose as many as filters. Every filter is going to give me a new some new information, some new value. So now if you come to this diagram was actually the same. Let us say this is the input image that you have, all of you, and there are 3 masks that I'm going to move on this image. Convolve this image with 3 masks. So the output that I get will be, I mean 3 masks, I mean 3 filters. So I'll have 3 as the, I'll have 3 such images as the output, because of this filter, and this filter. So this diagram itself is very clearly indicative of what actually is happening out there. Now if you can come down to, yeah, same diagram here. Okay, sorry, yeah, we were here. So this is what is happening. So I can have as many as here, for just for illustrative purposes it is shown 3. I can have any number of filters. Now let us take a look at this example. So what is W2 that I'll be having? W1 is 32. Is there any padding? No padding. Is there a stride? How much is the stride? Stride is 1. How many such filters do you have? You have 6 filters. So what will be the depth of the output image? It will be 6. Are you getting this part? This is the most important part. Again, coming back here, there are 3 filters here on this image of Taj Mahal. 3 filters were applied. So output, how many will I have layers? I'll have 3 layers. Now coming back to this diagram, this is the input image that you had, and you are operating, convolving 3 filters. You're convolving it with 3 filters. So output, how many filters will you have? 3. So you will have 3 here. So are you getting an idea? So just take a look, because last year the numerical was based on this particular concept. That is the reason I detailed it out. Now, after understanding the relation between input, output and size, which is governed by this particular formula, the last point that we have to see to understand CNN is pooling layer. I did tell you somewhere here, to understand the difference between a feed forward network and CNN, I did tell you that this operation will be clear later on. So what actually is happening with this particular operation? Do you remember I told you we will take the maximum of these 4 bits. So coming to the second last slide, what is happening is, this is the image that I have. I am taking 2 by 2 max pull with stride of 2. So I take this first first filter or first pooling. I am doing it using these 4 pixels. I take stride of 2. So after 3, I'm not going to put my mask on 4. Instead, I'm going to put it on 8. Of these 4 values, I'm taking the maximum, which is 6. So 6 comes up here. Of these 4 values, 8 is the maximum. So 8 is the value that I write here. Here, I write 12. Here, I write 9. Please remember, instead of max pooling, I can use any pooling that I wish to. I can go for average. I can go for minimum. I can take stride of 3. I can restrict it to stride of 1. So this is all, as we always tell, that there are no thumb rules for it. Is that okay? So which are the concepts that we have seen for CNN? We started with convolution. We saw kernels. We did note that the kernels are even sized. We did see the relation between the kernel, the input, padding, f, which was nothing but the depth, and the output. So having seen all of this, coming to the last slide, convolution neural network looks something of this kind. Something, I mean, there can be any number of layers. So let us start. What do we actually mean by this? And understanding this diagram will help you to solve all the examples which are given in the assignment and also in the last university paper. So let us take an example. um, uh, this example is, the same example, I'm trying to classify a digit. The digit that we have taken is 7. So the input is 7, and input I'm using a 32 by 32 window to slide it. Now this input goes to the first convolution layer. In this convolution layer, what is happening is the depth of the filter is 5. K is equal to 6. What is K? 6. So there are 6 filters which I have chosen. Maybe the first one was averaging, then it was max, then it was min, blah, blah, blah. Anything of it. There is no padding done on the input image, and I go for S is equal to 1. That is, I go for stride. Now forget this parameters, P-A-R-A-M, what is written is parameters. There are numericals on parameters which I'll show you in last 10 minutes. First, understand what is happening in this particular layer. So this was your first convolution layer. The way we went to our, if we go back to the very first example, what did we say here is, this was the input. I can have one layer of filters here. Then these filters, whatever they extract, I can give it to the next layer of filters for more deep learning. And this cycle can go on and on before I go to the classifier. So if you try and relate this out with CNN, this is exactly that is happening. So this is your input layer. You had first 6 layers of filters. Then it was given to a pooling layer. In pooling layer, what is happening? Do you all note? In this particular pooling layer, if these are 6, you will still have 6 here. Okay? In particular pooling layer. Please mark the stride here is 1. That is taken in pooling layer. Here we got the size reduced to 1/4. Why did size reduce to 1/4? Because we took stride of 2. So when the stride is of 2, size reduces to 1/4. And there's no need to remember it out. You'll always get it with the formulas also. So here the stride is 1. When the stride is 1, the size has reduced to half. So here it was 32 by 32. The filters that we have used is 28, let us say. This is the height and width which we have got using the formulas. I have used 6 number of filters. The depth is 5, the stride is 1, and there is no padding. Then it is given to a pooling layer. Again, so this happens to be first layer of filters. What am I doing by actually giving it to pooling layer? I'm again taking the significant of this particular part and I'm giving it to the next layer for learning, and so on. So now here in the next layer, I can choose to use, I have chosen to use 16 filters. If you remember a back propagation network, in back propagation fully connected back propagation network, the choice of using hidden layers and the number of neurons in that hidden layers is completely given to the researcher. Similarly, here, choice of using the number of convolution layers and the number of filters in that particular convolution layer is given completely to the researcher, and it's a conscious choice. So as I always tell, there are no thumb rules, but there are always some intuitions and some indicative directions which can be used when making these choices. So when you have this second convolution layer, again after that you have pooling layer. Please remember one important thing. The number of filters I use in convolution layer 1 is my choice, but pooling layer will have same number of layers. So here it was 6. Pooling layer, you're only choosing the maximum of each. So the layers will not decrease. Is that okay? Now you again have second layer with 16 filters. Pooling layer will also have 16 filters. And then you choose to use a fully connected network here, which the output is 120 nodes. Then again you have used a fully connected network here, FC2, the with 84 nodes. And then you use a final output with 10 digits, because your final output is, see, there are only two things which are fixed. Input is 32 by 32 and output is 10 classes. So input and output is what is fixed. If you go to feed forward also, this is exactly what was being done. In case of feed forward, you chose to do it, use a 4 by 4 matrix here. Input is 16, that is fixed. 10 classes are fixed. Between what jugglery you do is completely your training and testing and validation and using of activation functions, blah blah blah, everything. So even in this case, your input is a digit, final output will be 10 digits, 0 to 9. Between this, what you do, how many fully connected networks you use, how many convolution layers you use, all this is completely your choice to do. Is that clear, everyone? So do you understand this? Yes, class, are you all with me?
Yes, ma'am.
Did you get it, all
Yes,
of you?
ma'am.
Yes, ma'am.
All of you understood it properly, what is happening here?
Yes, yes.
Did you get an
So
idea?
can
I'll
you
give.
share the PPT also?
Yes, I'll definitely share these notes. And before we end last 5 minutes, I would like to walk you through an example. So, yes, dear, tell me.
Okay.
All of you, do you get the idea of what is actually happening with
Yes, yes.
getting an idea, right? Okay. I'll also share these numericals which I have solved. This was unit. Okay. Just give me a minute. This is CNN numerical that I have here. Okay. We are here. Yeah. Do you see a numerical solved on your screen?
Yes, ma'am.
Now this numerical is very easy. Once you have understood it, once you have understood the construction of neural networks, understanding the numerical will hardly take a minute. Let's go through it together. This is the network that we were speaking of. This was the input, the convolution layer, pooling, convolution pooling, and then this is our choice, deciding how many fully connected networks you have. Now, one question which always arises is the parameters that we are using at each layer. So this PARAM that you see at each layer is nothing but the parameters. So let us quickly see what basically do these parameters mean. These parameters are nothing but weights of the filters. Towards the end, you'll also understand how different, I mean, in comparison with back propagation, the parameters that we are dealing with are very less here. So let us quickly understand it out. The first convolution layer, okay, I have written it as a table so that it becomes very easy for you people to understand, and this is this is the way I suggest all of you to work with. So I start with the first convolution layer. The input they have already given, it is 32 by 32. The depth is 1. Now, what is the expected output? They have given me this information. What is the information? Stride is 1, F is equal to 5, and you have chosen to use 6 filters, and the input padding is 0. So how many parameters will I have? Let us take example of first filter initially. Now I use the same formula. Do you remember this formula, class? Okay, W2 is equal to W1 minus F plus 2P plus 1. So how much is your W1? W1 is 32. What is F? 5. 32 minus 5. That is nothing but 27. 27. Padding is 0. So 27 plus 0, 0. Plus 1. That is 28. Stride is 1. So do you see that this W2 and H2 we have calculated it? Okay, which is 28 by 28. This you have calculated. Now, there are 6 parameters. Please understand. 6 parameters. The depth of the filter is 5. Okay, so it's a 5 depth, sorry, F, the spatial extent. Is it a 3 by 3? Is it a 5 by 5? Is it a 6 by 6? What that filter is. So it is 5. It is not depth. I'm sorry. It's the spatial extent, the dimensions of the filter. That is 5. So if the filter is 5 by 5, it's a 5 by 5 filter that you are going to use in this case, and you have 6 such filters. Okay, so what will be the, how many parameters will you have? You will have 5 into 5 into 6. Each filter is 5 by 5. You have 6 such filters, and these 6 filters will be operated on one layer. Okay, input image, what is the dimension? 32 into 32 into 1. So it is 1D. So how many parameters will I need here? 1, which is the depth of the input image, plus 6 filters, each of dimension 5 by 5. So in the first layer, the parameters that I get is 150. Are you getting it, class? Is the first part understood, everyone? Should I do it once again?
No, ma'am, not necessary.
Got it properly? Okay.
Yes, yes, ma'am.
Okay. So now when we go to the pooling layer, in pooling layer, the operation that we are doing is a maximum. There is no weight that has to be calculated. So when I go to the pooling layer, there are no parameters that I have to work on. In the first layer, what was given to us? 6 filters of dimension 5 by 5. So these are the 6 filters. Dimension of each filter herein was 5 by 5, and you're going to work it out on a single dimension. So that was 1 into 6 into 5 by 5. Second layer, always remember, pooling layer will not have any parameters. Okay, so parameters in the second layer are -0 parameters. Because the stride is 1, I know that the output image, it will just be half. So the size of the output is 14 by 14. These are the 6 layers that you have. So even after max pooling, it will be 6. So the output will be 14 into 14 into 6. Okay, I have used a general terminology where I'm writing the depth at the end. So please mark it. Input, it was 1. Output, here the depth is 6. Again here the input, this acts as an input to the pooling layer. So input is 6. Output depth is 6. Okay, I'm doing it on purpose so that you understand the way I'm calculating the parameters. Now can we calculate it for convolution layer the similar way that we did it here? Okay, in convolution layer, stride is 1. What is the dimension of the filter? It is 5 by 5. You have 16 such filters. So when it comes to filters, how much will be the parameters? 16 into 5 into 5. Do you understand this part? Here it was 6 filters. Spatial extent was 5 into 5. So parameters of filters were 6 into 5 into 5. Here it will be 16 into 5 into 5. Here what did we do? 6 into 5 into 5 multiplied by 1, because your input had a depth of 1. Here in this particular convolution layer, 16 filters, extent is 5 by 5, and input, how deep it is? Again 6 layers. So do you mark this? The parameters that I have here will be These parameters are 6 into 16 into 5 into 5. Do you get it here? Can you compare this, all of you? It is 6 into 5 into 5. Here it is 16 into 5 into 5. Here input was only one layer. So into 1, input is 6 here. This pooling layer 1 acts as a input to the convolution layer. So input is 6. So the parameters that I have is 2400. Yes, class, everyone. Did you get this part, class?
Yes, ma'am.
Okay, ma'am. Yes.
Yes, ma'am.
Okay, all of you. Now this is the only thing that you had to, that was the most important part. Again, going to the next pooling layer, if you at all see. Okay, so next pooling layer, will there be any parameters? No. Can we do it together, class? The depth is 16. Is that okay? This will also be, depth here will also be 16. It is 10 and 10. Again, the stride is just 1. So the output will be half of it. Here it was 28 by 28. Stride is 1. So it went down to 14 by 14. Here it is 10 by 10. It will become 5 by 5. So if you go to the next layer, this pooling layers, this layer, okay, it is 5 by 5 and the depth is 16. The depth is 16 that you do. Is it okay? And the parameters are 0. Now comes the interesting part. Last part. When it is a fully connected network, okay, what is going to happen in this last part? How many neurons do you have in the output? 120. How many inputs do you have here? 16. Okay, so the input to a fully connected network is nothing but the output in the previous case. 5 by 5, 16 such filters. So the input to the fully connected network is 5 into 5 into 16 and output is 120. Output is 120. So how many weights will I need? 5 into 5 into 16 into 120. I'll again quickly show you the presentation so that you remember it. You can map it through. Okay. Everybody, can you see this? Sorry. Okay, everybody with me? Okay, here everybody, all of you, when it was a fully connected network, okay, when it was a fully connected network, if these are 16 and these are 5, how many weights did we need? 16 into 5. I mean, each of these 16 going to all of them. Are you getting it? So similarly, okay. Okay, so in fully connected network, whatever is this dimension, what was this dimension? 5 into 5 into 16. These neurons, these many neurons are connected to 120. So in a fully connected network, how much parameters or how many weights will we need? 5 into 5 into 16 multiplied by 120. I am adding plus 120 to it. What is this 120? Bias. Do you remember the concept of bias, everyone? There is a weight given to bias as well. So whenever I'm using a fully connected network, I'll add 120. Output neurons are 120. Each neuron is going to have a bias. So I have added 120. Similarly, next layer, input is 120, output is 84. So input is 120, output is 84. How many parameters will I have? 120 into 84 plus 84, because these output neurons, each one of them will again have bias. Moment there is a bias given, there will be a weight for it also. So these parameters are nothing but weights. Similarly, when you go to the last layer, input is 84, output is 10. Input is 84, output is 10. So how many parameters will we have? 84 into 10 plus 10. So it will be 850. So the total number of parameters will be this, which if at all you happen to compare with feed forward network are still substantially low. So is this part clear, class? Did you get the concept? Did you get the concept of this CNN and these pooling layers and convolution and the stride padding concept, finding out the height and width, finding out the number of parameters. Yes, class, are you all with me?
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes,
Yes.
ma'am.
Okay, so I'll share these notes as well, and this example which I have, which we will see, this is the example which is included even in your assignment. So it is the same example. I have also given the solution here, and it is done in the same way that we did it here. Same thing, first layer they have given it is an input image of 28 by 28 and 1, and it produces 64 outputs. If outputs are 64, how many filters will I have? 64. Here outputs are 6. So how many filters did I have? 6. Here the outputs are 64 and size is 3 into 3 into 1. So what is the input? 28 into 28 into 1. What is the output? It is 28 into 28. And how much is the output? It is 64. How did I get this 28 into 28? Again substitute it in the same formula. What was the formula? W2 is equal to this formula that we have used. W1 minus F plus 2P plus 1. So what is W1 in this case? W1 is 28. Is there any padding? Padding is 1. Stride is 1. And F is 3 by 3. So if I substitute it here, 28 minus 3 plus 3. So this W1 is 28. F is nothing but 3. 2P. So it is 2 plus 1. So 28 plus 3 minus 3. So the W2 and H2 that you get will be 22. Sorry, 28. And the parameters will be 64 filters 3 by 3. And they did not write into 1 the way I wrote it, because I wanted you to understand that depth will also get multiplied. 1 into 6. Then here you had 6 into 16. Same way. But then they have taken into account for pooling layer, no parameters. Similarly, same way it is done. Is this clear, class? Yes, class. Are you all getting the concept?
Yes, ma'am.
Yes, yes, ma'am.
Okay.
Yes, ma'am.
Now, just a couple of sentences I wanted you to very well know. There are 2 to 3 very important concepts which you should be prepared for from your oral examination point of view and your theory examination point of view. Concept of vanishing gradient, concept of dropout, concept of limitations of this sigmoid function, and limitations of convolution neural network. So please remember that these things, these couple of questions are also important. That what is vanishing gradient? What do you mean by zero-centered activation functions? Why are the zero-centered activation functions useful? What is actually happening with sigmoid? Why do you go to tan function? Why do you go to ReLU? Why do you go to leaky ReLU? And how do you train this CNN, which is nothing but your dropout concept is used in training the CNN. So these couple of theory questions, they are very important, and you should always expect some questions on this these points when it comes to unit 6. Is that okay, class?
Yes.
Okay, so all of you, everyone, was it useful, everybody? Did you get
Yes,
what is
ma'am.
happening with
Yes,
CNN
ma'am.
and okay? And these numericals, so if you see this previous year's question paper, the numericals are all based on finding out the sizes. So I want you to revisit this formula once again. So all of you, is that okay?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, okay.
Yes, ma'am.
Hansa is very tired, Hansa. Okay, that is okay, I understand. But then you still could have a good leisure time. Okay, so there's nothing you have to be tired of. Is that clear?
Can
Yes,
you suggest
Hansa,
what
we
to
would
do?
like to hear from you. Tired to listen to me and hear it out? All good going, rest of you? Taking good care of yourself?
Yes, ma'am.
Too much care, ma'am.
Too much care of yourself. That was Ajay speaking. I'm glad, Ajay. Where
Yes,
are you,
ma'am.
in Pune or in Nagar?
No, Ahmednagar, ma'am.
Ahmednagar. Take good care. All of you should take good care and
Yes.
Yes, ma'am.
and submit your assignments. Everybody, we have to start with the assessment, and I'm still waiting for you to submit the assignments. Is that okay?
Yes, ma'am. Okay.
Okay,
Yes, ma'am.
class. So should I end the meeting? Is there anything from your side, class?
Ma'am, just share the PPTs and previous PPTs also, so we can just
Okay.
study.
Okay, I'll do it. As I did tell you, the source, I had done that course on NPTEL course on deep learning. So it is completely by Mitesh Khapra. All diagrams today, every point that you must have seen, I have written source as Mitesh Khapra. I'll even
Yeah, we
share
saw
those
that
material
watermark.
things also.
Yes, ma'am.
Okay.
Okay.
Okay. Okay, ma'am.
Okay, class. Thank you so much for being there. Take good care and stay
Yes,
tuned.
ma'am. You
I
too.
hope you have received messages about your
Thank you, ma'am.
examinations. You can expect them anytime once things settle down to normalcy. Okay, so be prepared and
Yes.
utilize your time well. Okay.
Yes, ma'am.
Okay, class. Bye then. Let's meet soon. I'll let you know.
Yes, thank you.
Yes, ma'am.
Okay, bye. Bye.
Thank you, ma'am. Bye. Bye.
Shreya, thank you so much for coordinating it. A special thanks, Shreya.